Welcome to Into the Cockpit, where we examine the capabilities of advanced aircraft. Today, we're going to explore the technology that makes the F-35 a fifth-generation fighter. Now, to be fifth-generation, an aircraft must possess certain differentiating capabilities to include stealth, advanced sensors, information fusion, and network connectivity. And the F-35, that's all packaged together in a long-range, supersonic, highly maneuverable fighter. Come on, let's go take a look. This is the F-35, an advanced multi-role fighter. Now, there's three variants of the F-35. The F-35A was built for conventional takeoff and landing. The F-35B, which utilizes revolutionary lift fan technology to take off in short distances, accomplish hover operations, and land vertically. And the F-35C, with a larger wing, reinforced landing gear, and a specialized tail hook to permit operations on an aircraft carrier. Now, each variant meets a specific need, but all models of the F-35 provide the pilot with stealth and an advanced platform to gather information and disperse information across the battle space. So what is stealth? Stealth describes techniques that are used to make an aircraft less visible on radar. One of those techniques involves the use of radar absorbent material, or RAM. Radar absorbent material, or the outside coating of the aircraft, can be used to decrease or absorb radar energy so that the overall effect is that the aircraft signature is decreased. Another technique is by the use of the structure of the aircraft. The design of the wings, the fuselage, the tails, everything is combined together with very specific shapes and geometries so that radar reflections can be controlled to the max extent possible. Additionally, weapons and fuel can be carried internally or inside the structure of the aircraft, so the stealth characteristics are maintained while the aircraft is still fully mission capable. The F-35 has an advanced built-in sensor suite, one of those attributes making it a fifth-generation fighter. This is the Electro-Optical Targeting System, or EOTS. EOTS is integrated directly into the airframe of the aircraft. And what that means is there's no need to externally mount a targeting pod on the outside fuselage as is done on fourth-generation fighters. Now on the F-35, it's built right in. The system combines a forward-looking infrared and infrared search and track. With this design, the F-35 can detect threats like never before and identify areas of interest for flight operations. EOTS also gives the pilot the ability to precisely deliver laser-guided and GPS-guided munitions from their own aircraft or other allied platforms. Located in the nose of the F-35, right above EOTS, is the most advanced radar system in production. It is called the F-35 Active Electronically Scanned Array Radar, or AESA radar. An AESA radar is able to detect, locate, and identify multiple threats at long range, using both active and passive modes. It can simultaneously monitor air-to-air and the air-to-surface environment to provide situational awareness to the pilot. The AESA differs from previous radars in that it is composed of a single array of mini transmitters and receivers that form a beam of radio waves that can be steered and controlled electronically. That means there are no moving parts, and the array is fast, robust, and reliable. It's also capable of suppressing adversary air defense systems through electronic attack by directing RF energy at its targets. This mirrored window is part of the Distributed Aperture System, or DAS. DAS is a first-of-its-kind, 360-degree situational awareness producing system. DAS consists of 6 mid-wave infrared cameras located around the outside of the aircraft that create a protective sphere of information coverage around the F-35. The system points out threats such as missiles, relays precision tracking of wingmen, and provides night vision and fire control capabilities. In total, DAS increases the survivability of the aircraft in hostile battle space by boosting the pilot's situational awareness of the environment. In fourth-generation fighters, the pilot was responsible for observing and processing information from all aircraft sensors and using it to develop a unique mental picture of the operational environment. The F-35 reduces the pilot's workload by doing that processing for the pilot. The information from all the sensors is fused together to create one ever-evolving operational picture, a picture that is complete, real-time, and instantly usable. This process is called sensor fusion and permits pilots to operate with more speed and precision. So how does a pilot make use of all that information provided by the F-35? One way is through the use of the Helmet Mounted Display System, or HMDS. Now, each helmet is individually fit to the pilot to make sure that all the information that is displayed on the visor remains visible while flying the aircraft. And it's this fused information translated from the two-dimensional world of fusion into the real world. It's an augmented reality that puts all the basic flight information diffused data information and the targeting information right wherever the pilot happens to look. And oh yeah, here's the cool part. The DAS acts as an additional set of eyes, giving me greater field of view on the HMDS visor and cues to threats that my eyes may otherwise not see. Since the cameras are outside the aircraft, it allows me to look through the aircraft. I can also switch to night vision without having to switch additional equipment or add it to the helmet. All this helps me make critical decisions faster. Now that we understand 5th Gen tech in the F-35, let's see how these transformational capabilities are put to use by the pilot flying this advanced multi-role aircraft. In this scenario, a two-ship of F-35s is tasked with a reconnaissance mission in unfriendly airspace. As the F-35s cross into contested region, they use the F-35 stealth to operate within the adversary's air defense system. The F-35 sensor suite collects information, fusing it and cataloging it into relevant data to provide to the pilot. Increased situational awareness is instantaneous. The ESA radar scans for any threats, while EOT scopes the ground looking for areas of interest. Suddenly, the radar detects a patrol of rival aircraft beyond visual range. The information is displayed on the pilot's HMDS, and the F-35s turn to avoid them. The enemy patrol is heading towards a flight of 4th Gen Allied aircraft and haven't seen them yet. The F-35 shares the location of the enemy patrol through a U2 node to the 4th Gen flight, so they too can avoid the threat. The F-35s provide additional support to the Allied formation by actively jamming nearby radar installations, making it difficult for adversaries to locate the 4th Gen flight. The formation adjusts course and is able to avoid the enemy patrol. The F-35s continue their patrol when DAS picks up a missile launch from the ground located behind the flight. The F-35s transition tracking from DAS to EOS and then send the missile launch coordinates through a satellite node to a nearby ship to conduct a target intercept. The F-35s complete the mission, depart hostile territory, and return to base. That was a brief demonstration of the F-35's differentiating capabilities that make it the world's most advanced 5th generation fighter. Thanks for joining me today, and I hope to see you next time as we enter into the cockpit.